Hello, I'm going to go over this worksheet with you, analyzing and interpreting data, reaction rates. And what we have here is a simple experiment that can be done. It has all the parts of a lab that we would expect to see. It has a hypothesis, materials, procedures, some data that was collected from running the lab. And we're just analyzing what has already been done. So we're not actually running this lab, okay? So this is your information page. Your paper that you're actually going to be working on is the second page. And you're just gonna run through each of these. So what is the hypothesis of the experiment? Well, that's pretty easy to find. It's even labeled the hypothesis. Then we've got two things. What are the independent variables and what are the dependent variables? So to help you remember this, you want to look for something that, for the independent variable, the scientists control. This is the one thing that they picked. So you got to find that in this description. It's going to be one of these two things. It's going to be one of these two. You got to find that which one the scientists controlled and then write that in on the blank space. Now the dependent variable, that was the data that was actually collected during the experiment. So you look back at the experiment, you see the two pieces here. Well, one of those was actually the data that was collected while the experiment was running. And you should be able to figure that out by the procedures. All right, and you write down whatever that one was. Safety, so you're looking at safety concerns while running this lab. What are some of the safety concerns? Was there anything here in the procedures where somebody could have gotten hurt? Could somebody have gotten stabbed with something? Could somebody have gotten burned with something? Could somebody have inhaled toxic gases? Could rocks have fallen on top of a person? What are hazards or potential hazards here? So, you know, anybody could have different answers. There's not one particular answer. So look through it, see what could have happened during the lab. And then you write in, for this specific lab, what could have gone wrong. I don't see any big piles of rocks, so I don't think anybody could have gotten crushed by boulders. Now, graphing our data. Again, here's our data. And I'm going to help you set that up. So what we're going to do is on the bottom, we're going to put time. I'm sorry, the temp. That's why I wrote temp. And we're going to put that in Celsius. Okay. I'm going to start with 0 and go 10 degrees Celsius for each line over to 50. And I know that because I can see that my numbers are just 20 through 50 here. I don't have to go any higher. For the y-axis, that is going to be my time, and I have to put units in seconds. Now, the highest number I have there is 120, so I just have to have 120 on here. And I already know that if I start at 0 and go by 20s, I will reach 120 at the top. So that's perfect. I'm going to use most of this graph. If I look at my data table here, let's graph one. Temperature of 20, reaction time 120 seconds. 20, 120, right there. Let's do another one. Temperature of 30, reaction time 90 seconds. So that got faster. And you'll finish up graphing these last 2 points. And then finally down here at the bottom, was the hypothesis correct or incorrect? You are not telling me correct or incorrect. You are explaining why it was correct or incorrect. So you have to say what it was that made it either correct or incorrect. If you just put one of these down here, incorrect, that is horribly wrong. So have an explanation of whether the hypothesis was accurate or not. All right, thank you very much.